Hang in. Just wait a minute. Let me just reshare my screen. There's some problem. Okay. Okay. Now I hope my screen is visible. Now, basically, yesterday we were at a point where we were like destroying, we're moving around discretely and destroying objects. But now we'll use today we are going to use physics to move around, and I'll also cover some important things that we need to consider while developing something for physics. So basically we'll be reaching this point where we move around using physics, and maybe we'll also add some maybe coins in here while we are collecting when we collide with the when our player collides with the coins. So let's start. Let me just shut down this part. And if you have followed me completely through yesterday's workshop, then it's fine. You can continue from there. Else, what you can do, else when I have we have made you Unity project. So basically, you can go to assets. You can start a new project completely. Go to assets, import package, custom package, and this Amalthea underscore 2 unity dot package. You click on it, and you click on it, open it, and you should see something like so you should be seeing an import option over here, and you just click on import, and everything will be and you will reach the point where I am right now. So once you're done with this, drop a +1 in the chat. Okay, okay. So I guess some of you have done it. So I will repeat the instructions again. Go to assets. Go to import package. Import custom package, and wherever you have saved your Unity package that we sent over the mail, click on it and open it and import. And once you open it, you will get an import option in the Unity editor and import it, and you will reach where I was. And also open your Unity project in uh, also open your Unity project in Visual Studio Code. Sorry. Okay, so here we are. Okay, so we were at this stage yesterday. Okay, the recording for day 2 was shared with you over the email. Uh, yeah. So yesterday we were over here. Now what we want to do is basically get we want to have a character which moves around. Uh, so what we'll first of all do is go to this prefabs, and go to this prefab, and uh, basically uh, go to this prefab and scale them back to 1. We This is because we need have this link sign on, a constraint proportions enabled, and make this to 1, and do this for both the cubes. So after this, basically all our cubes will be like will be connected. So there won't be gaps in between. And second thing that I want to do is go to this go under your player, click on capsule, and go to the capsule collider and remove this component, and instead add a component. After this, after removing the capsule collider, go to mesh, and instead select cube. Uh, and now add component box collider. Okay. Now now if you play, you will be now once you play, your player has been changed to a box, but now we want to add some physics to it. So so Unity has a very nice physics engine, which they wrote in the rigid body script. So what you are going to do, select this player and add a component. Select this player and add a component. Not box collider. Add rigid body to it. Okay. And now if you play, uh, maybe get the start maybe get the start position really high to like 20, and now play. So you can see that your cube fell from a height. So this is because I have turned down. So this rigid body has an inbuilt gravity function written for us, and when it is ticked, we keep falling down. So let's go back to the original starting position and take off the gravity. Is your cube falling through the grid? So if your cube is falling through the grid, which means if your cube is falling through the grid, which means your cubes, the prefabs don't have a box collider set on them. So just go to your cubes. Wait a minute. Just go to the cube and ensure that you have box collider attached to them. And here on player, and also on this player capsule, you should have a box collider attached. Okay, cool. So now our player isn't colliding. Now, second thing I want to do is basically I just want to I don't want to destroy any of the styles. So in the player manager script, which is in your assets slash script, just comment this line so that we won't be destroying anything. So now you can see we are not destroying anything. But now what we want is we we want our this thing cube to move around. And but before that, I want to introduce some concepts of how physics works in Unity. And after that, we can sorry uh, sorry, I was muted in between. So first I'll explain some concepts of rigid body in Unity, how it works, and then we'll go on programming the movement. So now, what I want to demonstrate here is, so add a new object called add a new object queue, and like slightly take it further and duplicate it, and take the copy little to the right, uh, a little to the right. Okay. Now on the first cube that you generated, create a script called create a script called temp. We are going to delete this script. It's just to show some. This script is just to show you some things about just some demonstration about how to use the how to add forces and all. So once you click on the cube, uh, click on the first cube that you created, drag your temporary script to this, and open this temporary script in Unity, and also add this and also add the rigid body component to the script. And make sure you're ticking off the gravity for this cube. Okay. Now the thing is, now I want to add some force to this object. So in order to add some force to the object, I will have to reference the rigid body component. In order to do that, I will create a public rigid body, and we will call it RB. Make sure that your cases are correct. The R in the rigid should be capital, the B in the body should be small. And once you have written this, you will see the rigid body variable over here. You can just drag this rigid body into here. And now this RB basically refer to the rigid body of this cube. Now we want to add a force. So let's write RB. So rigid body has this function called add force. So if you go to Google and search rigid body dot add force, and go to this dot add force. So here you will get the documentation for add force, and basically it takes two arguments. It takes two arguments. One is the force, and another is the force mode. So the force is basically is sort of vector three, basically three floats, and force mode I will come to it later. So essentially, if you want to add force, you'll basically have to mention three variables showing in which direction you want to apply force. So I'll write it. Uh, so I am writing it in the void star. So I will add a force in x direction. Okay, so I will add force. So 0, 0, 0, and I want it to go in the positive. I want the cube to move in the positive x direction. So I will add some huge force on the right. So maybe like 10 or maybe some 10. Now if you play, okay, I didn't add a semicolon, my bad. Okay. Okay, now if I hit play, so basically maybe 10 is such a small amount of force. Maybe I will increase it to, or what I can do is I can add a variable over here, a public float thrust, and instead of adding force, I will add thrust my force, and you can update that value over here. Maybe I'll make it 100, and let's play. So you can see the object went and collided with the other. You can see the object. This cube went and collided with the other object, other cube. Okay, that's fine. Now what I want to demo, what other thing I want to demonstrate is that like okay, let's see over here. So now instead of calling this force function in the start, I am calling it in the update. And so the thing is now in update, update function is called in at every frame. So we'll be giving a huge force every frame. So let me just drop down the force to 1 and just remove this cube, like turn off this cube, set it inactive. So now if I play, so you can see that this cube is moving at some speed, and now if I play, the cube is moving quite slower than it was moving earlier. Now you might be wondering what did I do? I didn't do anything. So basically I just unplugged my laptop. I just unplugged my laptop charger. So when I unplug my laptop charger, my frame rate dropped. And the thing about the update function it is called once per every frame. So uh, so basically if it is called every frame, so this force will be applied to the object uh, on every frame. So if you have a good laptop, if you have a good laptop with very high specs, so then the force applied will be huge compared to if you have a old potato laptop. So in order to make this, and even on your same laptop, if you are like playing, if you are just playing this game or maybe have some background apps open, at that time also there will be some inconsistency in this update. So in order to make this function frame independent, we just multiply it by time dot delta time. Okay, so you should multiply it with time dot delta time. And now this time dot delta time is basically the difference between this frame and previous frame. So the overall force that is applied to your object over a second will remain the same, and it will be independent of the frame rate. So I'll just check up this value to like something like 100 again. Uh, and once I play, no matter even if I remove my laptop charger or not, it is moving at the moving at the similar speed. You are not experiencing any changes. So this part is something important that you have to do. Are everyone at the with me over here? Uh, Drop a +1 in the chat if you understood what I was trying to tell you. Okay. So I hope you got this point. Now what we are trying to do is what another thing that I want to show is so let's use this logic, like use this logic and code the control for our player over here. So let's just comment out all these lines. And the thing is, let's write if input dot get key down left. What I want to do is I want to add force in the left direction. So for us, uh, so for our player, the left direction is basically negative x. So we'll add a force in negative x direction. So I'll just copy this part. But before that, I will have to before this, I will have to reference our player. So just copy this part, these two things, and And now we can write this code, and basically now we will just reference this rigid body over here and increase the thrust to like something like 100. But uh, now when I try to press left, it's not moving as it is should be. This is because first of all, because it's in the left, I should be adding a negative number. I should be adding a negative sign first of all, because we want it to go in the minus x direction. And second thing is, I am using input get key down button. So due to this, what is happening that due to writing input get key down, uh, this function is only like this statement is only true at that one frame when I'm clicking this button for the first time. Else it is returning false. So instead of get key down, we'll use the get key function, and it will be true as long as I'm pressing my left key. So let's try this now. And this time let's use gravity. This time also take the gravity. Okay, so apparently the force is too less. Let me just boost up the force to like something like 1,000. Okay. Okay, so now you can see that I am able to add some force and our cube is toppling down to the right. So similarly, let's write this for all the directions. So if it's in the right, I want it to go. If it's in the right, I want to go it in the positive x direction. Else, if it is up, if it is up, I want it to go in positive z direction. Else in the negative z direction. So let me just ramp up the force again to 1,000. And now you can see that our cube is going in all the directions. But now the thing is our cube is randomly rotating. Uh, our cube is randomly rotating. We don't want that to happen. So what we can do, so the thing is the cube is rotating because of the friction. Like if you might have studied some physics in your 11, 12, so you know that if this is happening due to friction. So in order to remove the friction, we'll create a new folder, call it physics material. And in this we'll create a new physics material, you can see over here, and call it maybe no tumble, and reduce the dynamic friction and static friction to 0. And we'll and to and with the cubes that we had, we are going to the cubes that we had, we are going to add this material to the collider. Note this material to the collider for both the cubes. Okay. Now if you see, okay, I again have to. Okay, so the thing is, when you are playing the game, and if you change any parameter, it will stay as it is. But once you stop playing, it will return to its default value. So I'm changing the parameter outside, and now let's play again. So now you can see that the cube is moving, but it is still tumbling because the thing is all these are like separate objects. So there is very slight chance that these are like separate objects, and it's like the physics is not very perfect, so that's why they are tumbling. But if you would have had a single large cube, then this problem wouldn't have occurred. So we can fix it other way. So basically what you can do is in the rigid body of the player, go to this constraints and freeze rotation for x and z direction. So now you can see you are not tumbling now. Uh, but still due to those crevasses, you are still rotating in the y direction. Now you can like now you can freeze rotation in every direction and you won't be tumbling around. Okay. Now since this movements are done, uh, do you have any doubt till now? Else drop +1 if you are like following me here. Uh, okay, cool. So let's move further. So now what I want to do is I will tell you something about collision. So let's focus back to the two cubes which we had earlier, and let's take this cube also. And now in this go to this temporary script. Let's go to this temporary script, and so basically there is a pre-written function called on collision enter, which gives us the collision information. So let's go to again to Google and search on collision enter, and then you will get this documentation page of this function on collision enter, and it basically and this function will be as you can see this function will be executed whenever a collider collides with some other uh, collider. So this function will be executed. So let's just copy this function for now and write it here. And you can see that this function takes argument as the collision as the argument. So from and now this collision type of let's look into the documentation of this collision. So from this collision, we can get the information about other game object, like the other game object. So this uh, is my screen visible there? I would have turned my video on, but the thing is, like my system, like Unity is already heavy on my system. That's why I'm preventing from turning on my video. Otherwise, I was okay with it. Yeah. Okay. So back to where we were. Sorry for the disturbance. Uh, so this collision variable, or maybe let's rename it to something like other. So this variable is of the type collision, and as you can see in the documentation, you can get the information of Okay. So we can basically get the information about other collided objects. So so let's try to write a debug statement. Other dot collider, and okay. So I wrote a debug statement over here, and let's see what happens when this cube collides with that cube. So when this cube collides with the other cube, when this cube collides with the other cube, I am getting the that you have collided with the cube one collider. Okay. Now what I want to do is I want to destroy this other cube when I'm hitting the other cube. So to do that, instead of writing debug.load, I will write destroy uh, other dot collider dot the game object associated with it. So once I do this, so as you can see, once the object collides, the other thing is destroyed. But now I don't want this to happen. So instead, I want what I want is I want it to destroy after some time. So this thing I missed in previous class, that if you want to destroy like the destroy function takes another argument, another float value as argument, uh, and this basically means that the other object will be destroyed in 5 seconds. So let's do this. So once our object has been collided, the other object will be destroyed in like around 5 seconds. Okay, and we'll be continuing. Okay, so this is something about the on collision inter, and now okay. So after this, let's try to write something like let's try to generate some coins in our so let's try to randomly generate some coins in our uh, uh, on the screen, and our player will collect those coins using this function. So we can like turn off these two things and go to level manager and create another public game object called coin. And to create a coin, I will basically create a 3D object cylinder and vertically scale it down to point 0.05 maybe, and drop and enable the constant proportion, and drop it down to like uh 0.25 or something, or maybe zero point 0.2, and maybe rotate it by 90 degree in the y direction, sorry, in the z direction. And okay, this looks fine. And let's add some material to it. So create a new material and give it some yellowish color. Okay, So we have this coin. So I'll just create a prefab out of it. Okay. Now what I want to do is I want to randomly generate those. So so I want them to be randomly generated. And so also they should be generated within this frame only, within this 7 by 7 7 by 7. So go to our level manager, and in the start function, let's create another function called void generate coins. Make sorry, I was in the wrong script. Let's create another function in here called void generate tiles. Sorry, generate coins, my bad. and and it will like let's let it generate coins for now, and I will call this function in the start, and let's give an argument the number of coins to be generated. So int num coins as an argument, and let's create a public int which tells you the number of coins. Fine. uh, so let's make it to 5. Let's increase the number to 5. So basically you want to generate coins randomly. So so our cube in general is at a height of maybe so our cube is at a height of maybe 0.2475. So if we generate it at y equals to 0.25, it will be good enough. So so as we saw yesterday, we can use the instantiate function to generate this, but we need to generate num coins many coins. So we'll use a for loop, and we'll instantiate the coins. So I'll just copy this part of the code, and instead of tile prefab, we want to generate the coin. Uh, okay, I didn't add the coin prefab over here. So add the coin prefab over here, and generate the coin prefab. The location I want it to be randomly generated in some position. So I want its y coordinate to be 0.25 and 0.25 float, and I want this two numbers to be minus randomly generated between minus 3.5 to positive 3.5. So for that, there is a function called random dot range, and let's search for the documentation. Random dot okay, it's a random dot random. So this is the function random dot range. It randomly gives a float number between these two numbers. So so this random dot range will give like this function when called will give a float between -10 to +10. So let's copy it and the level manager. But we want it to be generated from minus n by 2 to positive n by 2. So uh, let's do that as well. Uh, so this is number of tiles. Okay, there's some syntax error. Okay, let's just have it this way. Okay. Okay, I guess the error is fixed, and let me just generate the coins. Okay, so they were not generated because I did not assign the prefab, but let's do it again. Go to the level manager and add the coin prefab. And now they should be generated. Okay, okay, so I don't want it to be generated at the so now the coins are being generated, but the problem is it's not that I want them to be generated. I should be able to collect them as well. So, and I also want their rotation to be something. I don't want them to be like this, and I want them to be rotating as well. So let's give them some rotation. Uh, so go to the prefab, open it, and okay. So apparently I had to generate it. So apparently I had to generate like I had to change the quarter neon dot identity argument of the instantiate. But before that, let's try to write a code for collecting the coins. So uh, in order to do that, let's create a go to this coin and open it. And here instead of tag, we'll add a tag called a coin. Okay, and now we give this coin tag to the cylinder. And now in our player manager script, uh, let's add this function which we added on collision enter. And and let's try to debug the other game. Let's try to debug the game object. So you can see you can so you can see when I am colliding with the cylinder, the console is giving the cylinder dot clone as into the debug. So when I enter this, I basically want to destroy them and keep a count of it. So I will go to the play. I will go to the player manager, add another public and score, and it should be initialized to 0. And basically, whenever we collide a game object which is of the tag uh, which has the coin tag, we want the score to increase. So basically, we have to uh, compare with the tag of we need to compare the tag of the other game object. So to so there's a compare tag function which can do that for us. So let's search for the documentation of compare tag. So this is what it does for us. So basically, we can do, instead of on trigger enter, we can also write on collision enter, and we write if other dot compare tag equals to whatever tag we wrote, that is coin, will destroy the other game object. So I'll just copy this part of the code. And if before destroying, we want our tag was written as coin over here. Uh, as you can see, this tag is coin, so we'll write coin exactly over here. And instead of destroying the object right away, I'll write debug.log. Uh, this is a coin. Just wait a minute. So apparently I'm running into an error. So instead of writing this is on collision enter, let's try to write as on trigger enter, and let's take the trigger for this coin. Let's try it again. So apparently the Unity might have updated this, but there's also another way we can achieve it rather than using tags. So that is instead of comparing the tag, we'll check if the other game object has a certain script attached to it or something like that. So this is basically a workaround. Uh, so we can create another script and call it isCoin, and add the script to this coin prefab. Sorry, my bad. Script. And let's add this. Okay, apparently I cannot add this until my errors are fixed. 290. Okay, now this should be fixed. Okay. Okay. Okay, fine. So let's just add this isCoin script to the other game object. And in this script, we'll just add like this is just a workaround. In this coin, a, uh, I just add a public integer and call it maybe call it something like coin, and in the editor I will set it to 1. Okay, and now what I want to check if this other object is if other object has the script or not. So in order to do that, again in this player manager, I will uncomment this and change it to on collision enter. this coin, and okay, this should do something. Oh, sorry, this game G should be small. I bet. I need to set. I also forgot. I need to set the set this collider to not untick the trigger basically. And let's try again. So whenever we are hitting a coin, it's telling it is a coin. So now what we want to do, we just have to destroy the destroy that particular game object. So here we will increase the score by 1 and destroy other dot game. And to destroy it, we just copy this part of the script. And we don't want to wait for 5 seconds to destroy it. We can just destroy it right away. And it's so now as you can see, when I move around the coin, I'm collecting it. And let's just debug the score as well. So here we'll just debug.log the score as well. Okay. So now if you move around, so you are like collecting the coins as well, and you are debugging the score. So that's how you kind of use the colliders. So I'll go over whatever we did today, and so I'm more or less done for today. Like, do you have any do you have questions till anything we did till now, or like drop a +1 if you followed till now, and I'll go over what we covered today. Okay, so I guess more or less everyone followed it. So I will go over what we did today. So basically first of all was we saw how to import an external package which we create on our own, and I'll also show how to create your own Unity package. So you can basically go to assets and export package, and you basically can export the entire project as a package. And once you export this once you export this something sorry once you create an export package, uh, a, a, f- a file of this extension .unity package will be formed. And once this is formed, you can import this package in some another project, another Unity project. That's something we did. Then we saw how do force a rigid body in Unity works. So a rigid body is basically the crux, like the very physics thing in the Unity. So and it is very it has very a lot of functions which can help us write other physics things like add force, and you can also add explosion and other things. But to teach it. I didn't go through it before preparing for it, so I'm skeptical about it. But it's very easy function to write. And Apart from that, we also looked into the looked how to make force frame independent by using this time dot delta time. We learned somewhat about the physics material. We can add or decrease we can add or remove friction, and we also saw how to randomly generate objects and all. And we also learned about how to use collider to get the information of collision and do something accordingly. You can also use collision functions to write something like for first person shooter game. You can write if you have a physical bullet model which goes and hits another player, so you can write a function that something like on collision enter other dot collider dot game object and get the script which contains the other player's health and decrease it or something like that. So you can do things like that with on collision enter. And similar to, and when I messed up in between, I showed you that there's this function called on trigger enter. So that basically that so when instead of on collision enter, if I do on trigger enter, uh, and let me not destroy this game object. Just wait a minute. And also set this player to sorry also set this to trigger. Sorry, not to set this player to trigger. We want to set the cylinder to trigger. My bad. So once we do this, something like, so you can see you can move through the coin. Uh, let's fix this error. The basically the parameter here should be of the type collider. Okay. Uh, okay. These are some Unity problems. But the idea is once you have this as let me just see that on okay, let's not use this function as well. I'll just tell you what happens when there's a trigger. So basically when the trigger is on, your game object can basically pass through everything, and now there are functions like there are there is this function on trigger enter. So I'll show you the documentation of it, or something on trigger state. So there is this a function called on trigger spray, and this will be called as long as your collider, as long as the object that the script is on is in some trigger. So something like if you want to code something like fire damage, so you are taking damage as long as you are on a fire. So a function like this would help. So and that's how that's the basic difference between trigger and collider. Trigger lets you pass through things, but now it has some function which tells you whether you are inside that. Uh, so yeah, that is more or less what I wanted to cover today. You have any questions? Uh, if not, I will be there for another like 5 minutes. Else we can end the session. So I guess you don't have any questions. Uh, so yeah, about yesterday's video lecture. I guess those were sent to you. If not, I will just drop the link again in the chat. Just wait a minute. Okay. So I confirmed the basically the mail has gone to the gone to the all the participants. So just check your mail if you have the if you received the link for yesterday's lecture. If not, like if you still face any difficulty, okay, I won't be coming anytime after this, but uh, okay, wait a minute. Okay. Maybe let me check with the people who are like sending the mails and all. I will, and then maybe again mail back to you again all over again. Is it what is the exact difficulty you are facing while deploying? Like or like if it won't take more than 5 minutes, then maybe we can do it right away. Else you can see the video. Okay, thanks for joining. We'll be closing this session now. Thank you.